Hi everyone, so welcome again to another video. That will be a reviewer or a sample problem video about trigonometry. So without further ado, I'll just discuss the examples. No, so we will only discuss plain trigonometry. Although I think it might be fitting to also discuss spherical trigonometry. But I guess let's just discuss the plane trigonometry. Since in the board exams, we only have plane trigonometry most of the time. So let's discuss. The first one is this problem. So given alpha, sine alpha is equal to x, what is sine or secant alpha? So for visualizing this, no, so we know that the trigonometric identity sine alpha will be just an angle, no, in the triangle or a right triangle. So a right triangle has an angle alpha, and if we said that this is equal to x, then therefore we are also saying that this is equal to x over 1. And what is sine? So sine alpha is equal to the opposite over the hypotenuse, no? So therefore the opposite here is equal to x, which is this, and then over, no, 1. Okay, so this will be x over 1. So if we want to find secant x, or sorry, secant alpha, that will be equal to what? So you have the hypotenuse over the adjacent. So the hypotenuse here is 1. But what is the adjacent? So the adjacent from this angle, or yes, the adjacent of this angle is this, right? So we can let this as, let's say, value z, ano? So z, we do not know yet if what is the value of z. So we can imagine we can solve for z here using the trigonometric, sorry, not the trigonometric, but the Pythagorean theorem, wherein the sum of the squares of the leg, so z squared plus x squared, is equal to 1 squared. So simplifying this, we can transpose this one and then solve for z. So z is equal to 1, no? So 1 squared is 1, and then minus x squared. Yeah. And then this is squared, so since this is squared, we can just find the square root to find the value of z. So z here is equal to the square root of 1 minus x squared. So therefore, this is also your adjacent sine. So we can write this as the square root of 1 minus x squared. Yeah. So this will be your answer. Yeah. Okay. Next one. So which is true regarding the sides of the natural function for angles between 90 degrees and 180 degrees? So we have 4 choices here. So let's imagine this problem in a Cartesian coordinate system wherein we have the x-axis and the y-axis. So if we said it is in between 90 to 180 degrees, so if this is 0 degrees, so we are rotating this in a counterclockwise fashion. So, sorry, I cannot erase this. So this will be 90 degrees in here. This will be 180 degrees, and this will be 270 degrees. So if you want to figure out what is, let's say, the site of this trigonometric function, we can create a curve here that has an angle with the x-axis. Dapat po yan, no? So the angle with the x-axis. So we can form this right triangle here with this side here and then this side here. So since this is your triangle, then we can find the sine or the if it is we can determine if it is positive sign or negative sign. So since this is in the positive y-axis, no, upwards, so this will be positive, this side will be positive, and since this is in the negative x, ano, side, then this side will be negative. And always remember that the hypotenuse is always positive. So therefore, if you want to find the tangent, okay, the tangent will be, we have tangent, let's say this is theta. So tangent theta will be equal to opposite over adjacent, which is positive over negative. So this will be negative. If you want to find for cotangent, this will be negative over positive, since this is the adjacent of this angle versus the hypotenuse, which is negative here. And then for cosine, so for cosine, we have the adjacent. So adjacent is this negative angle And then the hypotenuse, we have negative over positive. So this is negative. And then lastly, the sine, no? So sine is opposite over hypotenuse. So this will be positive, positive. Yeah. So this will be positive. So what is the answer here? So this is not positive. So negative, negative. This is negative. This is positive. So therefore, the answer is C. Okay, so in the following illustration, we have this angles 2 and 5, which are 90 degrees. So this is 90 degrees. And then we have DC. So DC here is 20. And then we have DC here is 20. And then we have BD. Sorry, BD ba? BD or BC? Sorry, AC pala, ano? So DC and AC. So AC is 25. So A to C here is 25. So I'll just write down 25. So what we're trying to find is the length BC. So this one. And BD. So this one on this length here. So what can we say about this triangle? As you can see, if we have an angle here that is alpha, then if we form a parallel line here, then this will be alpha, right? So if this is alpha and this is a parallel line, this will also be actually alpha. So if this is alpha and this will form a 90 degrees, this will form a 90 degrees, then this will be beta, right? So if this is beta, this angle is beta, and then this is alpha. Sorry, I think we swap this one also. This should be alpha pala, no? Sorry, this should be alpha. Ayan. So this should be beta. And then this will be beta. So as you can see, we have similar angles with this geometrical triangle, no? in your geometry. Then if this has the same angles, then they are similar triangles. So we can imagine we have here we have the triangle A, B, and D. So this triangle here is A, B, and D. And if you can see here, we have a similar triangle in here. And actually, as you can see, this bigger triangle here is also similar, no? So it has an angle of beta and alpha. And we know that beta plus alpha is 90 degrees, which is also this. So therefore, this triangle here, no? This is also what do you call this? Similar. So we have can you imagine this is C and then D and then A. So we have this triangle here. Ayan. So if this is 90 degrees, we can actually calculate this. We can actually calculate this side using the Pythagorean theorem. So this side will be, let's say this is R or AD. So this side here, AD, is equal to the square root, or sorry, not the square root, no? Since this is the hypotenuse. So we have 25 squared is equal to AD squared, and then plus 20 squared. So AD is equal to the square root of 25 squared minus 20 squared, which should be equal to 15, right? So we know that this is 15. So if this is 15, then AD here is 15. And what do you have here left? So we do not know this BD, you know. We're trying to find for BD, length BD. And for this one, for the similarity of this triangle, for the big ones, so the bigger ones here, the AD here is, I think I have this wrong, no? Sorry, the orientation is wrong. This should be D, no? Sorry, this should be D, this should be C, this should be A. Ayan. So if this is AC, we have 25, then DC is 20. And actually, you can calculate this already, you know. So using the ratio of these two triangles, so we know that the ratio should be equal for the same side. So 15 over 25 should be equal to BD over 20. So we can find the length of BD, which should be, oh, this is equal to 12, right? Calculate this. And then for calculating the BC, so BC is this length here. What we can do here is, since we calculated this side, no, as 12, so you can imagine this triangle here. We have a triangle that has a hypotenuse of 20 and a leg of 15. So to find this BC, we can just solve this Pythagorean theorem. So BC, since this is a leg, this is just the square root of the hypotenuse minus the square of the leg. So this is equal to, actually this should be 12, sorry, this should be 12 pala, no? 12. So this should be 16. Okay, that's it. Next one, so a vertical angle at the top of the flagpole from point A on the ground is observed directly, or it's observed to be 37 degrees, 11 minutes. The observer walks 17 meters directly away from point A and the flag point to point B and finds the new angle to be 25 degrees, 43 minutes. So what is the approximate height of the flagpole? How do we do this now, no? So let's visualize the problem. So let's say we have a flagpole, and from point A, it is observed to be 37 degrees. So we have an angle of elevation that is 37 degrees. So you can imagine, let's say we have a flagpole here. So this is the flagpole. And then let's say we have a horizon to the ground. And then let's say this is point A. So the angle of this, from this point A, looking at the top of the flagpole, will be 37 degrees and 11 minutes, right? And then it says that the observer walked 17 meters away from point B, from point A. So this will be your point B, right? And then this will be 17 meters, the distance between these two. So we have another angle, looking at the top of the flagpole, which is 25 degrees and 43 minutes. So what can we see here? So we have a triangle, no? We can form triangles here. And we want to find the approximate height of the flagpole. I will just call this Y for now. Ano? So what can we see here, no? If you could imagine, we have two triangles. So this is the first triangle. We have 37 degrees, 11 minutes, and then we have this Y height. And then another triangle is the steeper, the less steep one, the longer one, which has an angle of 25, 43, 23 degrees, 43 minutes, and with a height of Y. But the distance here, we can imagine we have X here. Sorry, not X, but 17. Sorry, 17. And then this will be, we can let this distance here, no? Let's create an arbitrary variable. Let's call it X. Yeah. So the distance here is, let's say this is X. And then therefore, the total distance of this leg will be 17 plus X. Ano? So this will be X. X. So we can create a relationship between the angles here and the sides. So for this first triangle, we have tangent 37 degrees, 11 minutes. So we choose tangent since we have a given opposite and an adjacent side. So this will be Y over X. Now for the other triangle, we have still an opposite and an adjacent side available. So we have tangent 25, 43. That is equal to Y, no? The opposite is Y, and then over 17 plus X. Okay, so this is your two equations to unknown. So if we have two equations to unknown, how do we solve this? We can solve by substitution, ano? So we can write this one as X is equal to Y over tangent 37 degrees and 11 minutes. And we can substitute this to our second equation. So we have here an equation that is 25 degrees, 43 minutes is equal to y over 17 plus we have y over tangent 37 degrees, 11 minutes. So as we can see here, we have only one given variable for the single equation. We can just solve this directly through a function in our calculator, the shift solve. So we can just input this in your calculator. So let's see how do you input this. So we have tangent. So be careful, it should be in degrees. So mode, shift mode, and degrees. So we have tangent 25. So degrees, 43, another degrees, no? So if we have the second degree here, it means minutes, okay? And then equals, we have y, so alpha x, and then we have 17 plus we have alpha x over tangent 37 degrees, 11 minutes. Okay, so shift solve. So shift solve for that. So we have 22.43. Okay, so the height of the flagpole is 22.43 meters. Okay, now, so the expression cosecant theta cos cube theta tangent theta is equivalent to which of the following expression? So we have given trigonometric identity that is a product of each other. We want to now figure out which of these four choices is equivalent to this original problem. So let's try simplifying this. If we can simplify this given problem into one of these four choices. So what the strategy that I will do is I will try representing this three trigonometric functions into just functions of sine and cosine for the sake that we can cancel them out, you know. So we have cosecant here, so this will be 1 over sine theta. Okay, and then for cos cube, so since this is already cosine, so I will not change this for now. And then we have tangent theta, which is sine theta over cosine theta. So as you can see, we can cancel out this sine theta here. We can cancel out this cosine theta, reducing this exponent by 1. So what is left here is cosine squared theta. Now, what is the trigonometric identity that we should use, since this is not yet present here, no? So one of the Pythagorean identities that we should remember is the Pythagorean theorem or Pythagorean identity, wherein if we have sine squared theta plus cosine squared theta, this is equal to 1. So therefore, if we want to solve for cosine squared theta, we can transpose this to the other side. So we have cosine squared theta is equal to 1 minus sine squared theta. So therefore, this will be your answer. So simplifying this will be 1 minus sine squared theta. So this will be letter C. So what is the value of theta? We satisfy the following equation. Okay, so how do we do this? If we have this given equation and then we want to solve for theta, we can actually directly use the fifth solve function. But since this is in radians, so the mode should be in radians. So we can do this directly already, but analytically we solve this. Since this looks like a potential. Select the find theta. Now this alphabet. We can use the theta is equal to u, which is equal to -1. So we can just omit this u here. Sine theta is equal to -1. And then sine theta is also equal to -3. So if we do the inverse sine, we have arc sine. So theta here is arc sine -1. And then for this one, we have arc sine. Sorry. of negative 3. So using your calculator, you have to first adjust your calculator into radian mode. So shift mode 4 and then input the problem and then mode calc, no? So mode 1 computational. So shift sign and then negative 1, we have negative pi over 2. Negative pi over 2. So this will be negative pi over 2. And then for negative 3, so we do not have a solution. So no solution here, no? Okay. So therefore, this should be your answer. Although the required answer here, it should be less than 2 pi. So how do you imagine that? So if you have here the Cartesian coordinate system, or actually this should be the polar system, no? But anyways, if we have here an angle of negative pi over 2, so we have to adjust the angle clockwise. So if this is negative, this should be clockwise. If it is positive, it should be counterclockwise. So we have to adjust pi over 2, that is equivalent to 90 degrees, no? Or negative 90 degrees. So this should be your side, no, of your triangle. So if this is your side, then therefore using this, no, so we have 0, we have this is pi over 2, this is pi, this is 3 over 2 pi, and this is also 2 pi. So therefore the angle that we should use here, if this should be less than 2 pi, or it implies that it should be positive but less than 2 pi, then the answer should be 3 pi over 2. So this should be your final answer. So given the triangle with angle C, side A, units, okay, so solve for angle B. Ayan. So if this is the case, then we do not know, no, if it is a right triangle. So probably this will be an oblique triangle if we have two given sides and an angle. So let's visualize this. So for specifying triangles, so a convention that we use frequently is that the angles, let's say A, angles B, and angle C of these vertices of this triangle will be the opposite. The opposite side will be the smaller letter of their angle. So the angle A, the opposite of this angle will be the side A in small letters, and then for C that will be the same. So small letter C, and then B for B. So for this given, we can visualize what is angle C, which is 28.7 degrees, and then side A is 132 units, and then side B is 224. Then therefore we want to solve for angle B. Now we have two tools, no, for oblique triangles. We have the sine and the cosine law. So for angles, usually we use sine law, so we can have a relationship of sine B over its side, and sine C, capital C, over sine over the side C. So since this is the given angle, that's why we utilize the angle C, So we have the given C angle, we have the side B. We do not know the angle B. We also do not know the side C. So we want to solve for C first before we can solve for the angle B. So therefore, to solve for the side C, we should use the cosine law. So for the cosine law, it is only applicable for included angles, no, and then two given sides. So included angles meaning if you have two given sides, the center angle or the included angle should be given. So the angle in the middle of these two sides. So therefore, to calculate for C, we have C squared is equal to A squared plus B squared minus 2AB cosine 28.7 degrees. So we have this given, and actually this should be angle C first, no? So to find for C, this will be just a square root of this. So we have A squared, which is 132 squared, plus 224 squared minus 2 times 224, and then 132, and then cosine 28.7. So the answer should be, so I'll just write down the answer since I already calculated this. This will be 125.42. no? So in units lang, no? So since the unit is not specified, you can just write here units. And then for the angle, so we are actually looking for the angle. So to solve for angle B, so since this is already given, we can solve for angle B. So sine B uh, is equal to, so cross multiplying this to the other side, we have B over C sine C. So therefore B here is equal to arc sine of B over C. So we have 224 over 125.42, and then sine C, which is 28.7 degrees. Yeah. So using your calculator, you have to remember that this should be in degrees, no? Since the given is in degrees. So shift mode and degrees, and then we have arc sine 224 125.42 sine 28.7. And so this will be 59. So B here is 59.06 degrees. Okay. So do we have another? Yeah. So for the last example, two ships leave a dock at the same time. One sails northeast at the rate of 8.5 miles per hour. It could be meters per second, no? But usually this should be miles per hour. Mi per hour, no? And the other sails north at the rate of 10 miles per hour. How many miles apart are they after 2 hours? So two ships leave a dock. So we can imagine here a dock, and then a two axis coordinate system, the Cartesian coordinate system. So this first ship leaves the dock northeast. So northeast meaning it is 45 degrees angle, no? Or 45 degrees here. So we have here it leaves at 8.5. So yeah, I will not write this down, only this one for now. So the rate at or the speed of this ship is 8.5 mile per hour. And then for the other ship, so the other ship sails north only, no? So north only, so it goes north, so at 10 miles per hour. So let's say this is his position at some time. So how many miles apart are they after 2 hours? So after 2 hours, what is their distances? So we can rewrite this triangle. So we have this distance. So we are trying to find for the distance after 2 hours. So we can imagine we have a triangle, an oblique triangle, with a distance here that is 8.5 miles per hour multiplied by 2 hours. So this should be 17 miles, right? And then for the other one, it will be the same. So 10 miles per hour. And then we have to multiply this by 2 hours. So there should be 20 miles. And then what are the given? Also, we have a given angle here, 45 degrees. And this is also 45 degrees since this is northeast. So we have a given side or two given sides. We have two given sides and an angle in between. Therefore, we should use the cosine law to find this opposite, no? So the opposite here, let's call this x, ano? So x squared is equal to 20 squared plus 17 squared minus 2 times 20 times 17, and then cosine 45. So therefore x is equal to, so yeah, let's calculate this. So x squared, so make this a square root. Yan, also 20 squared plus 17 squared, and then minus 2 times 20 times 17 cosine 45. Okay, so we have 14.43 meters. Yeah, so this will be your distance in miles, yeah, no? So it's not in meters. Yeah.